At the boundary of space, there's still enough residual atmosphere that a spacecraft traveling at hypersonic speeds is going to be slowed down by the atmosphere, and it needs a propulsion system to keep it aloft. Otherwise, those collisions with the residual air at the boundary of the atmosphere will just deorbit your spacecraft. And there's no good propulsion solutions right now that enable the spacecraft to stay aloft and sort of like indefinitely. We were selected among a few other teams across the country to come up with some radical new solutions to solve this problem. And we found that the small satellites in particular, which can be really economically efficient, you can accomplish a lot with one small satellite or a few small satellites that are much cheaper to build. But the thing that's really hard to do for the small satellites is a propulsion solution. So that's what we're focused on, is a propulsion solution that would work for a small satellite. In my field of electric rocketry or building electrically powered propulsion systems for spacecraft, actually the last 60 years have all been using one type of propellant. And that propellant is xenon. It's a noble gas, and it's gotten really expensive. And people have become to ask the question of could we do this better? Are there other options out there? But to answer that question, you really have to understand fundamentally how the propellant behaves. The new propellant that we've designed is really cool. It's actually, instead of it being every molecule that you're accelerating, we're actually accelerating discrete particles. So we're sort of specifically designing these nanoparticles to have the characteristics that we want to have the optimal thrust performance and the sort of miles per gallon performance in our system. Space and space technology is just as critical a part of our infrastructure for our world now as anything else, like roads, cars. So by making this, this infrastructure more efficient and more effective, companies, individuals can take advantage of it, and we'll see reduced cost for, all of these things. That this will be a part of our ecosystem and our infrastructure that is operating more efficiently.